Namaste children. The next chapter is sound. Sound is a form of energy produced by the vibration of the particles of a medium. These vibrations are created when disturbance is caused in the medium. Sound plays an important part in our daily lives. It helps us to communicate with each other. We hear a wide variety of sounds in our surroundings. Sound is produced by a vibrating body. Vibration is the to and fro or back and forth motion of an object. Example, if you strike a school bell, it vibrates and produces sound. If you pluck a stretched rubber band, it vibrates and produces sound. If you beat a drum, its stretched membrane vibrates and produces sound. If you blow a bulb, the air column vibrates and produces sound. These are some examples of musical instruments which are producing sound by stretched strings or by stretched membrane or by the air columns. Production of sound in musical instruments depends on the type of instrument. There are 4 types of musical instrument. Woodwind, that is air column vibration, string, stretched string vibrations, percussion, stretched membrane vibrations, brass instruments. Instruments make music by blowing on the top or on a reed of the instrument. For example, clarinet, boson, etc. Now coming to the string instruments. String instruments make music by plucking or strumming the strings. For example, violin, veena, guitar, etc. Next, percussion instruments. Percussion instruments make music by striking, shaking or scraping the membrane stretched or by beating them. Brass instruments make music by buzzing lips while blowing. For example, trumpet, clarinet, tuba, these are etc. The examples of musical instruments. And these are some examples of musical instruments and the vibrating part which produces sound in them. For example, veena, sitar, violin, guitar produces sound by plucking the stretched string, whereas tabla, mridangam, drum, these will be by the stretched membrane. Shahnai, flute, mouth organ, these are due to vibration of air particles in the air column of the instrument. Some musical instruments produce sound when they are beaten or struck. For example, bell, ghatam, manjira, jaltaran, etc. Sound produced by humans is by the vibrating voice box or larynx. In humans, sound is produced by the voice box or larynx. It is the upper part of the windpipe. 2 vocal cords are stretched across the voice box, leaving a narrow slit. When the lungs pours air through the slit, it vibrates and produces sound. These are the different parts of voice box. Sound produced by animals. Animals like dogs, cats, horses, lion, cows also produce sound by their vocal cords like human beings. Birds produce sound with a ring of cartilage called syrinx in their windpipe. Insects like mosquitoes and bees etc. produce sound by vibrating their wings rapidly. Frogs produce sound by puffing their vocal sacs up their throat like balloon while propagation of sound. Sound requires a medium to propagate. Sound travels through solids, liquids and gases. Sound does not travel in vacuum. Sound travels through the solid thread of a cantilephone. A whale listens to the reflected sound, that is echo in water, to locate its prey. We are able to listen to sounds because sound travels in air. Speed of a sound. Speed of a sound depends on the elasticity that is the ability of an object or material to resume its normal shape after being stretched or compressed. The density of the medium through which it is propagating. Speed of sound depends upon the two factors, that is elasticity and density of the medium. In case of air, it also depends upon the temperature of the air. The speed of the sound through air is about 330 meters per second. The speed of sound through water is about 1500 meters per second. The speed of sound in solid is greater than liquid and liquid is greater than gases. The speed of sound in gases is the least. Relationship between the speed versus frequency and wavelength. Speed of sound is equals to wavelength and into frequency. That is, speed of sound is the product of wavelength and its frequency. So, if we designate the speed of the sound with V and wavelength by lambda and frequency as nu, V is equals to nu lambda. Speed of sound in different media at 25 degrees centigrade. Now, speed of sound in different media at 25 degrees is given in this. Now, speed of light versus speed of sound. The speed of sound in air is about 330 meters per second, whereas the speed of light in air is about 3 into 10 to the power of 8 meters per second. So, speed of light is faster than the speed of sound. That is why when thundering sounds are always heard a little after seeing the flash of lightning, even though both lightning and thundering occur together. Delay in hearing is due to the difference in the speeds of sound and light. What is meant by vibration and oscillation? Vibration is the to and fro or back and forth motion of a particle of the medium. An oscillatory motion is the to and fro or back and forth or motion of an object. It is called as oscillatory motion. The motion of the pendulum from one extreme position to other extreme position and back is called as one oscillation. For example, here is given the motion of a simple pendulum. So, A to B and back to A through the main position O is called as one oscillation, whereas in vibration, the particle of the medium vibrates. The particle of medium is set into to and fro motion by disturbing the medium, and it creates a wave which is known as a mechanical wave, that is longitudinal wave. So this mechanical waves needs a medium for propagation. Example of mechanical wave is sound waves. Frequency of sound wave. The number of oscillations per second is called frequency. It is represented by the symbol nu, a Greek letter. NUE is the spelling. The unit of frequency is hertz. Time period of a sound wave. The time taken for one oscillation is called as time period. It is represented by capital T. The SI unit of second is S. Frequency and time are represented as follows. Time is equals to reciprocal of frequency mathematically. So, nu for one oscillation is reciprocal of time period. Amplitude of the sound wave. The maximum displacement of vibrating particle in the medium from its central position or mean position is called its amplitude. For example, in the wave is disturbed and causing the particle vibration transfers from one particle to another particle. So, when it is happening so, it creates the upper positions and lower positions. The upper positions are called crests and lower positions to the time axis is called as crests. So, the distance between two successive crests or two successive troughs is known as wavelength, and the maximum displacement of the vibrating particle from its central position is known as amplitude, and it is designated by capital A. Sound wave is the highest of the crest or trough. It is represented by the letter A. The SI unit is loudness and pitch of the sound. Till now, we have learned amplitude, time period, frequency, and wavelength. Those are the characteristics of a sound wave. Now, coming to the characteristics of sound, that is loudness and pitch. The loudness of sound depends upon the amplitude of vibration. If the amplitude is less, the sound is feeble. If the amplitude is more, the sound is loud. The unit of loudness is called decibel and is represented by small d and capital B. Next, coming to the pitch of the sound. Pitch of the sound is also known as shrillness, or it represents the shrillness or flatness of the sound, which depends upon the frequency of vibration. If the frequency is less, the sound has low pitch. If the frequency is more, the sound has high pitch. That means pitch is directly proportional to frequency and loudness is directly proportional to the amplitude. So, for example, sound of a drum, sound of an adult, etc. are low pitch, whereas sound of a whistle, sound of a baby, etc. are high pitch or shrill sounds. Structure of human ear. How we hear sound through our ears. Sound enters the ear through the ear canal, which is filled with air. It makes eardrum to vibrate. The vibrating air in the ear canal sets the eardrum or tympanum to vibrate, the particles of the tympanum to vibrate. The eardrum sends these vibrations to the inner ear. From there, the signals go to the brain by auditory nerve, and then we can hear the sound. So, auditory nerve here converts these signals into electrical signals and sends the message to the brain. Structure of the human ear. The outer ear is called pinna, collects the sound waves. The sound waves passes through the ear canal to a thin membrane called eardrum or tympanum. Eardrum vibrates. The vibrations are amplified by the three bones of the middle ear called hammer, anvil, and stirrup. The middle ear then transmits the sound waves to the inner ear. The inner ear, the sound waves are converted into the electrical signals by the cochlea and sent to the brain through the auditory nerves. The brain then interprets the signals as sound. Part of the inner ear which is connected to the auditory nerves. Like in eye structure, retina, how the optic nerve is connected to the retina. Here, auditory nerve is connected to the cochlea. Persistence of hearing. The sensation of hearing of any sound persists in our brain for 0.1 second. This is called the persistence of hearing. Persistence of hearing helps us to get a feeling of continuity while hearing one sound after other. Due to the persistence of hearing, the direct original sound and reflected sound reaching ear in lesser times than 0.1 second mingle together and do not produce any separate sound of their own. This saves us from confusion and difficulty. A repetition of sound produced by the reflection of sound waves from a wall or mountain or other obstructing surface is called echo. If we shout or clap near a reflecting surface like tall building or a mountain, we hear the same sound again. This sound which we hear is nothing but the echo or reflection of sound. Echo is caused due to the reflection of the sound. To hear an echo clearly, the time interval between the original sound and the reflected sound or echo must be at least 0.1 second. If we consider time period of sound is 0.1 second and speed of the sound in air 330 meters per second, distance traveled by the sound in 0.1 second is equals to 33 meters. So to hear an echo clearly, the minimum distance of the reflecting surface should be half this distance, that is 330 by 2 meters, that is equals to 17 meters approximately. Some examples where a reflection of sound and direct sound. The loss of reflection of sound follows the loss of reflection of light. Overlapping of these echoes, reflection of sound, multiple reflections of sound is nothing but the reverberation. Echoes may be heard more than once due to repeated or multiple reflections of sound from several reflecting surfaces. This causes persistence of sound called reverberation. In big halls or auditoriums, to reduce reverberation, the roofs and walls are covered by sound absorbing materials like compressed fiberboards, rough plaster, or trapeyers. A reverberation is perceived when the reflected sound wave reaches our ear in less than 0.1 second after the original sound wave. Since the original sound wave is still held in memory, there is no time delay between the perception of the reflected sound wave and the original sound wave. The two sound waves tend to combine as one very prolonged sound wave. Example, if you have ever sung in the shower and we know that you have, then you have probably experienced a reverberation. An inaudible sound. Audible sound is the sound which we can hear. It has a frequency between 20 hertz to 20 kilohertz or 20,000 hertz. Inaudible sound is that sound which we cannot hear. It may be below 20 hertz or more than 20 kilohertz. It has frequencies less than 20 Hz and more than 20,000 Hz. Sound whose frequencies are more than 20,000 Hz is called as ultrasonic sounds, and below 20 Hz are called as infrasonic sound. Some animals like dogs can hear ultrasonic sound. Bats can produce ultrasonic sound. Human beings can hear sound frequencies between 20 Hz to 20,000 Hz. So it is called as sonics. Sound whose frequency is less than 20 Hz is called infrasonic sounds. Animals like dogs, elephants, rhinoceros, whales, etc. produce and hear infrasonic sounds. Sounds whose frequencies is more than 20,000 Hz is called ultrasonic sound. Animals like dolphins, bats, rats, Propiosis, etc. produce and hear ultrasonic sound. Bats use reflection of ultrasonic sound waves to detect an obstacle or noise and musical sound. The unpleasant sounds are called as noise. Noise is non-rhythmic. So it is produced by irregular and non-periodic vibrations. If all the students in a classroom speak together, a noise is produced. Sounds produced by horns of buses and trucks. Noise, musical sound, sound which is pleasant to hear is called as musical sound. It is produced by regular or periodic vibrations. Sounds produced by a musical instrument which is played by a musician. Sound of a person singing a song or of excessive or unwanted or undesirable sound in the environment is called noise pollution. Causes of noise pollution. Noise pollution is caused by sounds of vehicles, explosions, including bursting of crackers, machines, loudspeakers, etc. In the home, noise pollution is caused by television, radio, and music systems at high volume, some kitchen appliances, desert coolers, air conditioners, etc. Harmful effects of noise pollution. Noise pollution causes several health related problems like lack of sleep, hypertension, high blood pressure, anxiety, etc. A person exposed to loud sound continuously may get temporary or permanent impairment of hearing. Measure to limit noise pollution. Noise pollution can be reduced by using silencers in vehicles, industrial machines, and home appliances, reducing use of vehicle horns, running TV, radio, and music system at low volumes, planting of trees along roads and buildings also help to reduce noise pollution. This slide shows some examples of noise pollution. Hearing impairment. Hearing loss, also known as hearing impairment, is a partial or total inability to hear. A deaf person has little to no hearing. Partial disability is generally the result of a disease, injury, or age. Sign language. Sign language is a language that uses manual communication to convey meaning. This can include simultaneously employing hand gestures, movement, orientation of the fingers, arms, or body, and facial expressions to convey the speaker's ideas. Here are some images given for sign language aids. Hearing aid is an electronic battery operated device. It receives sound through its microphone, which convert these sound waves to electrical signals. These signals are amplified and given to the speaker of the hearing aid. The speaker converts these amplified signals back into sound. This amplified sound is then sent to the ear, and this helps the affected person to hear it much more clearly. Of sound. Like light, sound gets reflected at the surface of a solid or liquid and follows the laws of reflection. That is, the angle of incidence is equal to the angle of reflection. The incident ray, the reflected ray, and the normal at the point of incidence all lie in the same plane. Now here is an activity to show the reflection of sound. Take two pipes of the same length and arrange them in a table near a wall or metal plate. Keep a clock near the open end of one of the pipe and try to hear the sound of the clock through the other pipe by adjusting the position of the pipe. Now measure the angles of incidence and reflection. Then lift the second pipe and try to hear the sound. It will be seen that the angle of incidence is equal to the angle of reflection. The incident ray, the reflected ray, and normal all lie in the same plane. Uses of multiple reflections of sound. Megaphones, horns, musical instruments like trumpets, shehnais, etc. are designed to send sound by multiple reflection in a particular direction without spreading in all directions. Doctors listen to the sounds from the human body through a stethoscope by multiple reflection. The sound of heartbeat reaches the doctor's ears by multiple reflection. Generally, the ceilings of cinema halls and auditoriums are curved so that sound after multiple reflection reaches all parts of the hall. Sometimes a curved soundboard is placed behind the stage so that sound after multiple reflection spreads evenly across the hall. Sonar. Sonar stands for sound navigation and ranging. It is a device which uses ultrasonic waves to measure distance, direction, and speed of. Sonar has a transmitter and detector installed in ships. The transmitter produces ultrasonic sound waves which travel through the water and after striking the object in the seabed is reflected back to the detector. The distance of the object can be calculated by knowing the speed of sound in water and the time taken between the transmission and reception of ultrasound. If the time taken for the transmission and reception of ultrasound is t and the distance traveled is 2d by the ultrasound, then 2d is equals to vt or d is equals to vt by 2. Measuring like this the depth of the sea by the sonar is known as fathometer.